show that x equals radical 5 is a 0 to this polynomial and use that result to find all zeros. So we'll start out using synthetic division, and we'll take the x value that we know, which is x equals square root of 5, and we'll use this in the synthetic division process. So in the top row, we'll go the coefficients of our polynomial, 1x to the fourth, plus 1x cubed, minus 7x squared, minus 5x, plus 10, and put our division bar underneath. In the synthetic division process, we carry down the 1 and then multiply. Radical 5 times 1 is radical 5, and then we add these together. But these are not like terms, so we're left with 1 plus radical 5. Then we multiply. Radical 5 times 1 plus radical 5. So we don't get lost, I'm going to do this over to the side. We're going to take radical 5 and distribute it to both terms in the parentheses. This gives us radical 5 plus radical 25. But the square root of 25 is 5. So we can simplify this to 5 plus radical 5. That's the answer that goes next in our chart. And then we add these together. We combine like terms. The negative 7 and the positive 5, we can combine them to give us negative 2 plus radical 5. And then we multiply. Radical 5 times negative 2 plus radical 5. Let's write that off to the side to make sure we don't make any mistakes. And we distribute the radical 5 to both terms, giving us negative 2 radical 5 plus radical 25. But just like before, the square root of 25 is 5. So we can write this as 5 minus 2 radical 5. That's the next spot in our chart. 5 minus 2 radical 5. And then we add these together. Combining like terms, the negative 5 and the positive 5 cancel, leaving us with just negative 2 radical 5. And then we multiply. Radical 5 times negative 2 radical 5. I'm going to write that over to the side. Multiplying these together gives us negative 2 radical 25. But radical 25 is 5. We can simplify this by multiplying these together to give us a negative 10. Finally, we add these, and they cancel to give us a remainder of 0. Because the remainder is 0, that tells us that x equals radical 5 is a 0. That confirms the first part of the question. Since none of the coefficients on this polynomial are radicals, they're all rational, we know that if x equals radical 5 is a 0, then its conjugate, x equals negative radical 5, is also a 0. So let's continue the synthetic division with x equals negative radical 5. So we'll carry down our division bar and carry across. We bring down the leading coefficient, and then we multiply. Negative radical 5 times 1 is negative radical 5. Combining like terms, the radicals cancel, leaving us just the 1. And then we multiply. Negative radical 5 times 1 is negative radical 5. Combining like terms, the radicals cancel to leave us with just 2. And then finally, negative radical 5 times negative 2 is positive 2 radical 5. Adding these together, they cancel to give us a remainder of 0. So x equals radical 5 was another 0. And then finally, what we're left over with, this reduced polynomial. Well, to get the degree of this, the original polynomial was degree 4. So after our first successful synthetic division, that knocked this polynomial down to degree 3. After our next successful synthetic division, it knocked the degree down again to x squared. So this leaves us with 1x squared plus 1x minus 2. Since we want to find all the zeros of this, we'll set this equal to 0. And now we can actually factor this. This factors as x plus 2 times x minus 1. Setting each factor equal to 0, this gives us x equals negative 2 and x equals positive 1. This was a degree 4 polynomial, so we should have 4 zeros. X equals radical 5 is the first one. X equals negative radical 5 is the second. X equals negative 2 is the third. x equals positive 1 is the fourth, so we know we have found all the zeros.